Yes, so I've completed my bachelor's in statistics from St. Xavier's College this year.
Okay. Okay. And have you appeared for any other examinations?
Yes, I appeared for JAM.
Okay. How you think you performed?
Could you please repeat? Your voice is really.
What is your performance in JAM?
I secured rank 40, AIR 40,
Okay.
so
Okay.
it
That
was
is
all
good.
right.
And how do you performed in PSA and PSB?
So our semester 6 results just came out. I got
No, no.
9 point overall. How
I am
was it?
no. I am asking that how you have performed in entrance, ISI entrance.
Sorry, ISI entrance. So I got 99 on the PSA,
That's
and
great.
in the
Okay.
PSB I attempted about 7 questions.
Oh, nice. Okay, so I am starting with a mathematical questions. Write it. So write A1, A2, dot 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 AN is a sequence, and I can't see it. Can you take it closer? No, the problem is I think the light is reflecting.
Is it visible now?
Uh, okay, okay. Okay, okay. Yes. And and A1 into N takes values 0 or 1. Okay. N is fixed. Okay. And N is fixed. And another thing is A1 into A1 into no A1 into A2
A1
A1
into
into A2
oh,
yes plus A2 into A3 plus dot 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 plus AN minus 1 into AN plus AN into A1 is equal to 0. Okay. Now, can you say something whether N is even or N is odd?
no, I cannot say anything about that.
Oh, okay. One thing, A1N takes value in 1 and minus 1. Okay, not 0 and 1. Okay.
Oh,
Now, can you say something?
I think N is even.
Okay. Why?
Why is N even?
Yes, obviously. Why are you thinking?
So there are basically N terms in this sum. So for the sum to be 0, N by 2 of them have to be minus 1 and the remaining have to be 1. Otherwise the sum cannot be 0. So if it's odd, then we cannot divide it into two equal parts. So
Okay.
it can always be that one half is one half is more negative than the other half.
Okay. So n will be even, right? Now, can we say something whether 4 will divide n or not?
Whether 4 will, acha.
Okay. If n is even, then n is either 4k or 4k plus 2 form, right?
Yes.
Okay. So I am asking whether 4 will divide n or not.
It may not divide it. If n is even, if n is not a multiple of 4, then it will not divide.
Obviously, no. I am saying that in this case, can it happen that n is not divisible by 4 still it holds is equal to 0? This condition met. Okay.
Oh, okay, I understand. Yes, so if let's say n is 2 and
It will not work, right?
huh?
It will not
Sorry,
work. Just a1
it
and 2
will
is
not
equal to
hold.
0.
Yes, because if n is 2 and I can let's say take a1 is 1 and a2 is minus 1, so we
It will
can
never
say
be
that it
0.
will still hold even if it's not divisible by 4.
I don't get you. Can you repeat?
Yes, so you asked me whether n has to be divisible by 4.
Yes.
Right. So let's say I'm taking an example. I'm saying let's say n is equal to 2
Okay.
and a1 is 1,
a2 is
a2
equal
is
to minus 1.
minus 1.
Then a1,
Then,
a2 is equal to minus 1.
oh, sorry.
Okay.
Oh,
You can try with n is equal to 6. Okay. Uh, then you will get what is happening. N is equal to 2 is very small. You have to put 3 1 and 3 minus 1, right?
yes.
Can you assign that?
It's not holding for 6. I mean,
Yes.
for the given choices that I've taken, it's not holding.
Okay. Even if you change the choice, still it will not
It will
hold.
not hold. So
So you
then
have
it
to,
has to be divisible by 4.
obviously, but you have to prove that, right? So, giving you a hint. So, what is the possible value of a1 into a1 into a2? What is the
1
possible
or
value of a1
minus 1.
into 2? 1 or minus 1.
Yes.
In first place, to show 2 divides n, you claim that you are adding n terms who takes value in 1 and minus 1, and sum is 0, then 2 will divide n surely. Okay, so you already use the property of sum. Okay, now can you use some property of multiplication? Not a1 a2 takes value 1 or minus 1. Can you do something by multiplying some terms? Okay, not another thing. If you have n is equal to 4k plus 2, then you will have 2k plus 1 or 1 term, 2k plus 1 minus 1 term, odd,
Yes.
right? Okay, you use this fact and multiply some terms or all terms to
Yeah.
conclude.
This is odd, right? So
Yes.
if I have a total of 4k plus 2 turns, then the number of turns in each group will be odd. So
Okay.
in that case, uh, I'm summing an odd number of turns.
You cannot proceed anymore with sum. Okay, because you have already used it. You have to think something different. The nice property with 1 and minus 1 is if you product them, it will uh, push you to minus 1. So
Yes,
product will help you in some way.
yes, I'm trying. I know I have to use that. So
Okay. Take a product of a1 a2 into a2 a3 into a3 a4, then see what happens.
product of uh, A1 A2 into A2 A3.
Yes, yes, yes. To a3 and in this way.
Okay, so this is basically, so this is always 1.
Yes. Okay, let's
Okay.
try a question from Emily. Okay, do you get the
Okay.
solution?
Yes, actually, because if there are 2k plus 1 terms here, then
Okay.
the product of the terms in this group That is always going to
You,
be plus 1.
yes.
Same for this.
Then
Because so so we cannot, so when we sum it we actually cannot get 0.
I didn't get you. Can you give your argument clearly?
So no, I cannot use this.
Okay, no problem. Let's move with a question of Emily. Okay. Uh, you know maximum likelihood estimation, right?
Yes.
Does Emily always exist?
uh, no, MLE may not exist.
Can you give an example?
Yes, I can give an example. So
Okay.
uh, let's say I have a random sample from a Bernoulli P distribution,
Okay.
and the parameter space that I have decided for P is that it belongs to this set S, where set is basically uh, it's the set of all irrational numbers
Okay.
lying between 0 and 1. All right.
Okay. Okay.
So when I can calculate, okay, fine, I'll just say it. So the MLE of P is basically X bar.
X.
It's very easy to show.
Yes.
And
Yes.
X bar is always a rational quantity
Okay. Okay.
because the values of X1
Good.
and X, it's rational. So
Very good.
the MLE cannot belong to some place outside of the
Yes.
parameter space.
Yes.
So
Yes. Yes. Okay. Okay. Thank you. Okay. Jit. Okay.
Hello, Arshiya.
yes, hello.
Okay, so let's begin with my part. Have you attempted PSB question number 10?
Yes, I have attempted question 10.
Okay, so tell me what do you mean by a linear model?
A linear model is basically an equation that, uh, so I'll give an example. So it's an equation that quantifies the relationship between a response variable, which I can call y, and a set of predictors, x1, x2, xp. And it's called a linear model because it's linear in the parameters of the model, which are beta 1, beta 2, and beta p.
Perfectly all right. What do you mean by a Gauss Markov linear model? And mention it assumptions.
Okay. So I had mentioned this, right?
Yeah.
So let's say I have taken n observations on y. So I can n observations on y and n observations on each of the x1, x2, x3 as well. So I can write it as this already. So I can write this in a matrix form. Take this. So this is basically the matrix form representation of this linear model.
Okay.
So this is a Gauss-Markov model, and the assumptions are as follows. So we assume that y is a random quantity. It's a random vector, and the randomness due to y, the randomness in y is due to the randomness in this epsilon curve. And we assume that the matrix X, which is the matrix of the predictors, is a non-stochastic matrix. And beta 1, beta 2, beta p, those are the unknown parameters of the model. And about epsilon curve, we assume that they are distributed, they have a certain probability distribution with mean 0 and variance sigma square. So they all have the same variance. And they are also independent of each other. So each EI is independent of another EJ, where I is not equal to J. And we also assume that N is greater than equal to P.
N is greater equal to P.
Because the number of observations is greater than equal to the number of parameters.
So why do we do that? And why we don't assume normality for epsilon?
It is not necessary to assume normality for epsilon unless we are testing some kind of problem. So the only reason we need normality is if we want to perform a test, and it is easy for us to find the distribution.
Yeah, and in fact also the estimating the parameter that beta gal of that model. Yeah.
Yes.
So
Yes.
can you state me the Gauss-Markov theorem?
Yes. So my model was basically y is equal to x beta curl plus epsilon. So it states that the estimate of beta curl, which is obtained by solving the normal equations, is the best linear unbiased estimator of beta curl.
Can you state me that unbiased estimator?
Yes. So the normal
That's the
equation.
least square estimator, right?
Could you please repeat?
That's the least square estimator, right?
Yes, it's the least square estimator.
Can you state that?
Yes. So basically the normal equation is this. If we solve it, it boils down to this. So beta hat is basically x transpose x in x transpose y.
Okay, so from that normal equation, you are coming to that, and that's the best linear unbiased estimator
Yes.
for beta gal. That's the Gauss-Markov theorem. Perfectly all right. Now, from that normal equation, you are just taking out the inverse of x transpose x. So,
Yeah.
is it necessary that it's always invertible?
Necessarily, actually, the X matrix it's an n cross p matrix, right? So X transpose X is a P cross P matrix.
Yeah.
So it is invertible if the rank of X is P.
So it may not be, right? Because X and Y are data.
Yes, it may not be invertible, right?
Yeah. So if it is not invertible, can we get beta cull hat LAC?
I think from this, no, we cannot, because we cannot obtain the inverse of X transpose X. So we cannot invert X transpose X.
So beta cull hat LAC is actually the expression you have written, that is only when X transpose X inverse exists, right? But
Yes.
beta cull hat LAC is something which will solve the above normal equation. That is X transpose X beta cull equal to X transpose Y cull.
Yes, right.
Okay. So the solution of that have nothing to do with the existence of that inverse. That's a system of equation. If you correctly identify it, it's a system of equation.
Yes.
Okay. And it doesn't have anything to do with the existence of the inverse of X transpose X. So
Right.
are you sure that the solution will not exist if X transpose X is not invertible?
No, no, that's not what I meant to say. I meant to say that if the rank of X is less than P, then of course we cannot write it like this. But
Yes.
I think solution will always exist.
Solution will always exist, right?
Yes.
So can you prove
Yes,
that?
I can. Yes. Explain. This is the system of equations that we are dealing with. So
Yes.
we will. So we will always have a solution for beta if the rank of X transpose X is the same as the rank of X transpose X augmented X transpose Y. It is possible to show that this holds.
That means precisely if X transpose Y cull belongs to the column space of X transpose X, right?
Yes.
That's the idea.
Yes,
So
that is.
can you show that it actually belongs to the column space of X transpose X?
Yes, I can try. So, you can always say this because this matrix is obtained by adding a column to X transpose X. So the column space of X transpose X will always be a subset of the column space of X transpose X augmented X transpose Y. So from this, we can say that rank of X transpose X is less than equal to rank of X transpose Y. So this is one side. Now rank of X transpose X augmented X transpose Y. This is basically rank of X transpose into X augmented. So this is less than rank
Why that rank of X transpose and that what you've written?
Yes, because this is X transpose X augmented X transpose Y. So that we can obtain that by multiplying this and this. This is a matrix. X augmented Y curl is a matrix. And if we pre-multiply this matrix by X transpose, then we'll get X transpose X augmented X transpose Y.
What you have written, rank of X transpose bracket A.
Yes. So I'll write it again. So rank of X transpose X augmented X transpose Y. I've written this as rank of X transpose multiplied by X augmented Y. We can write that.
I am asking that why, because rank of X transpose X and
This is the same matrix. That's what I'm saying. This matrix is equal to. I'm not saying that these are different matrices. These are the same matrix. isn't it?
Okay, proceed.
Yes, so this is less than rank of X transpose because this is a matrix, so by that, and this is equal to the rank of X. So from one side we have that, oh, just a minute. This is equal to the rank of X transpose. So from one side we have that rank of X transpose X is less than X transpose X augmented X transpose Y. And from the other side, we have the opposite. So they must be equal.
Okay, and I am actually confused at the second last line. I am unable to understand why you are, because there is X transpose X augment X transpose Y curl, and by keeping that X transpose, you are augmenting inside X. I mean X transpose. You are taking the bracket X augment Y curl, right?
Yes.
And there are two X transpose and one X on the left, but on the right you are considering one X transpose and one X. Are we allowed to do that?
I mean, what I what I'm trying to say is X transpose Y. So if this is X, I'm adding a column to that. Right. So this is a matrix and Y curl is also a matrix. So when I'm pre-multiplying this by X transpose, I am actually
No,
multiplying both of
I
them.
am not incubating Y curl. I am incubating X transpose Y curl.
Yes.
Are you able to get my point?
Yes.
I am incubating not Y curl, but X transpose Y curl. But where the transpose is going on the right side, where you have written rank of X transpose inside X augmented Y curl.
You're saying that I cannot write that this is equal to this.
I am not saying that you can't write. I am just saying that do you have the idea why we do so?
No, I don't have the.
Okay, just give it a check.
Okay.
Uh,
I mean,
okay.
if it's possible to verify this with any arbitrary matrix X and an arbitrary Y, then we can sort of
In
say
fact,
that.
you don't need to go by this also. You can go by column space also. That's a very easy idea rather than going into this algebra of rank.
Okay.
Because column space of X transpose X is same as the column space of X transpose. So it
Yes.
is what? It is the collection of all the vectors, say delta col, such that delta col is some X transpose, say Z col, where Z col belongs to R to the power n, and so you can say that X transpose Y col, where Y col is belonging to R to the power n, X transpose Y col will also belongs to the column space of X transpose, which is same as the column space of X transpose X. That's enough.
Okay. I
Okay,
see. I
that's a
understand.
more easiest argument rather than going into that algebra of rank. Okay.
Okay.
Okay, but make sure that once, I mean, the professors they check, okay, once you are writing the steps, I mean, you should have the idea. If not the entire derivation, you should have that intuition that why I am writing this step from the above. Okay, so my next question is uh, the problem that was given in PSB 10, that was not a usual Gauss Markov setup what we have done, right? There was a restriction on the parameter.
Yes, there was a restriction.
Yeah, if you drop that assumption, you will see that theta I hat ml is yi, and if we go with that assumption, you will see that theta I hat ml is most probably yi minus 2.
Hmm.
But
Yes.
that's a linear model though, because the parameters, I mean, you are modeling yi and the predictors as a linear in the parameters. Okay, you are modeling y and the predictors linear in parameters, so that's a still a linear model. whatever be the restriction on the parameter, that doesn't matter. But if you check the variance by dropping that assumption, you will see that the variances are same, because by dropping that assumption or by including that assumption, the MLE just varies by a origin shift, right? And variance really doesn't bothers about that,
Yes,
so the
right.
variance are equal.
Hmm.
So but in Gauss-Markov theorem, we have learned that a linear, I mean, theta cal hat LAC is the best linear unbiased estimator. That is, for any linear unbiased estimator among the class of linear unbiased estimator, it will have the least variance. But here you can see that the variances are equal. So does that anyway violate the Gauss-Markov theorem?
So when we had that restriction, actually,
Yes.
so that basically means that theta 1, theta 2, theta 3 are not independently estimated. Right, because if I know theta 1 and theta 2, then I can find theta 3 from that.
It does.
So,
So does that anyway violate the Gauss-Markov theorem? Because you are getting that theta I equal to theta I hat ML is yi minus 2 itself by least square, but with the assumption that theta 1 plus theta 2 plus theta 3 is 180 degree, right?
yes.
That's itself a least square estimator. But if we drop that assumption, but still the variance becomes same, which is the usual Gauss-Markov model. Do these two things have any discrepancies?
In the Gauss-Markov model, we don't put any restriction on the beta i's, on the parameters.
Very good.
So, I mean, the problem that was given, I don't know if we can treat that as a Gauss-Markov problem, because I mean,
No,
there
we
was a
can treat that.
restriction on.
I mean, Gauss-Markov linear model, it is a form of a Gauss-Markov linear model, of course, because you can write it and y equal to x theta plus epsilon. Though there are some restrictions on the parameter, but you can write it in a form of a Gauss-Markov linear model where x matrix will be an identity matrix. What's problem in that? It is doable. But now, so if you so Gauss-Markov linear model usual problem becomes deferred. Here the problem was just to estimate the theta without any restriction, but here we have to estimate the theta, least square estimator of the theta you have to find with that restriction, right? So by keeping that restriction, the theta hat you have found, okay, is this the blue? My question is that, is this the best linear unbiased estimator itself? I mean, theta 1, theta 2, theta 3, if you stack them, they are y1 minus 2, y2 minus 2, and y3 minus 2, stacking of that as a vector. Is that the best linear unbiased estimator for that theta cal hat LAC for our problem?
I think for our problem, yes, it is. But if we did not have that restriction, then the estimates would have been different.
So you are claiming that theta cal hat LAC in our case with that restriction is the best linear unbiased estimator. But we have found that it is the maximum likelihood estimator. So you are claiming that the MLE and the blue here are equal.
Yes, yes.
Okay, and that's the least square also. So what's the reason of doing that? Can you tell me?
So I think the reason behind that is that we have assumed that the errors are normally distributed. So when we assume that the errors are normally distributed, then the maximum likelihood estimates and the least square estimates are same.
Yeah, that's perfect. Can you think of any another distribution for which we can do that, or it's not doable, or it's very hard to think?
Uh, Least squares, I don't know if there is any other distribution. But if we change the method of minimizing the errors, then maybe we can find another distribution for which.
No, you can find the least square estimator. I mean, why not? Because least square estimator usually deals with the sum of the squares of the error and you minimize them with respect to the parameter. You end up with a normal equation, we end up with a solution. That has
Yes,
nothing to do with the normality on the epsilon, right? But what is the advantage that you can find out the MLE,
yes.
right? And they run in parallel, that MLE and that least square estimator, because of that normality. Yes, you are correct. Because only of the normality we can say that they are equivalent. Otherwise, we can't say. Now, so in epsilon, for our convenience, in the course that we have done in our undergraduate, so we have always assumed epsilon as normal distribution, right? I mean, for ANOVA and cohort regression, everything. So, can you tell me one test to check that whether a set of observations, say epsilon 1 to epsilon n, they are not known to you, they are random observations I have given you. Can you test me that? Can you perform a test for me that they are really comes from a normal distribution or not based on a sample of size n?
Um, Whether they're actually normally distributed or not. So
Yeah.
I know a large sample test. So if any
Can you
sub,
name it?
yes, so I can basically test whether gamma 1 is 0 and uh, gamma 2 is, I mean, this thing, u4 by u square minus 3.
Okay, I mean you are going that way. That is large sample symmetric mesocartic knot. Is
Yes,
that
I mean, that is what I know. I mean,
okay? So can you name that test and how can you test that? I am not asking about the derivation, but do you know how can we test that thing? There are other ways too for large sample only. That's more suitable rather than going in this way. You can find the large sample distribution of that sample skewness and sample kurtosis using delta method, multivariate delta method. You can do that, but things will get complicated. Can you think of some simpler tests that we usually do in our parametric and non-parametric literature?
yeah, I'm not aware of that. The only test that I know is to check for normality is this.
Have you studied Pearsonian chi-square?
Yes, I have studied.
So can we use that to test it?
Pearsonian, I mean, but in Pearsonian chi-square, the distribution of the resultant statistic does not depend on the distribution of the values that we are actually taking. So how does that, I mean, how could that tell us whether they
Don't
are
know the distribution, right? The observation, we don't know the distribution. We are
yes,
trying to test whether it is normal or not. Beforehand, we have no idea. You are having just a data.
yes,
So we can use Pearsonian chi-square. Why not? Because Pearsonian chi-square doesn't say anything that where from the data is coming, right? It just said data comes from a particular distribution. Under H0, we particularly check that what is our hypothesis, that from which distribution it is coming. Nothing else. We can use that. Do you know any non-parametric test? As non-parametric was a part of your undergraduate course for that. Not for particularly normal, for any distribution. I have given you, suppose say x1 to xn is a random sample from any particular form of a CDF and it is continuous. And I am telling you to test that whether you can test it, whether it is coming from a particular set of distribution or not, particular distribution or not. May it be normal, Cauchy, anything.
We haven't done that test actually. We haven't tested where a particular
Have you done
where the
Kolmogorov of test?
but yes, I've heard about that test. I've read about that. But doesn't that tell us whether the observations are coming from an absolutely continuous distribution, or
No,
does it tell us about the exact form of the distribution?
you can check that whether Kolmogorov-Smirnov test in usually suppose x1 to xn are IIT capital Fx. So our hypothesis is h naught is Fx equal to f naught x, where f naught x is completely known, right? That's the hypothesis. So I am telling you to check it for normality or any sort of distribution, say Cauchy or anything that is known to you.
Then we can test using
Yeah, we
numbers.
can test that using Kolmogorov-Smirnov and anything else, right?
Yes.
Though there are many discrepancies, suppose you have tested that it is from for a moderate sample size or a small sample size. If you test that whether it is normal distributed, if you test it for Cauchy, then also you will see that your Kolmogorov-Smirnov is telling you that yes, it is from Cauchy also. Okay, so it will. So can you name any test that can discriminate whether a sample is from which can discriminate a sample from normal and Cauchy? Because these two are more alike. They looks alike, right? Bell-shaped curve, symmetric. So, can you suggest any test which can discriminate between them?
So we could basically, so we want to test that, let's say H naught X comes from a normal distribution versus H1, X comes from a Cauchy 0, 1 distribution. So let's say I want to test this. So I could use the most powerful uh, level alpha test to test this.
No,
So
no, any
basically,
non-parametric test. You don't have any prior idea about the data and you want to perform any non-parametric test, whether they are coming from actually, do you know how, I mean, normal and Cauchy looks, though they look same, but do you know where they differs, normal and Cauchy distribution?
so if I have a standard normal distribution like this, then yes, a Cauchy distribution would look like this.
So they both are symmetric, bell-shaped, and they differs in their tail, right? As you
Yes,
have drawn the picture.
yes.
So there is a test that can discriminate distributions based on their tails. Have you done that?
No, I have not done that, but can we, it's not a test, but intuitively, if we think about it, so if the absolute value of, let's say, an observation, if that is less than some c, or I mean, what I'm trying to say is that the probability of an observation originating from, let's say, this portion is more for a normal distribution as compared to a Cauchy distribution.
You are trying to test that, right? That's the testing problem. So if in a testing problem, you must have some test statistic, must have some critical region. I am not telling to write everything, but do you know that what is the test that can discriminate between that can discriminate a sample between say normal and Cauchy distribution?
No, I don't. I haven't read it.
Okay, okay. That's Anderson-Darling test that that discriminates two distribution when they look very similar. We don't use usually the Kolmogorov-Smirnov and Pearsonian chi-square, but we rather use the Anderson-Darling test where it can discriminate the sample based on their tails, right?
Okay, I see.
So that's the idea. Okay, that's all from my side.
Okay, so do you know convergence in distribution?
Yes, I know.
Hello.
Yes.
Okay, so suppose x1, x2, xn is a sequence of distribution where xn follows uniform 0, comma 1 by n.
Xn
xn
follows.
0, comma 1, uniform 0, comma 1 by n. So find its limiting distribution. Hello, what you have written there? Like, I cannot see it properly. Yeah, when x is less than equal to 0, like, what is the first range of x there in your limiting distribution?
X less than 0.
Then what will the value take? It is 0 basically, right?
Yes.
Okay. And when is 0 less than x less than what we have written?
I mean, as n tends to infinity, this will also tend to 0. So,
Yes. Okay, so you are written 0 there. Okay. And
yes.
when x is greater than equal to 0. Okay. So when is x is greater than equal to 0, will it be 1? Can it be 1
No, it can.
when
Of
x is
course,
equal to 0?
no, it cannot be.
So rewrite it.
It is not a DF. It does not converge.
Yes. What are you telling?
It does not converge to a DF.
No, write it properly. Like write the proper form of the limiting distribution. Write it properly. Write properly the range. Okay, so you have written when x is less than equal to 0, then it's 0, and 1 when x is strictly greater than 0, right? You have written that, na? Okay, so why it is not a CDF? Why are you telling that it is not a DF? Hello?
Yes, it's just a minute. It's not.
Okay.
It's not right one though. I mean, so this is the CDF of f and x.
Yes.
0 when x is less than 0,
Yes.
and it's nx if 0 less than x less than 1 by n.
Yes. Okay.
So, so it will basically, when I take the limit, it will be infinity when
But check the range also. Change the range of x also. It will pull it down. It will pull it back to 0. Sorry, it will pull it back to 1. Isn't it? Like
oh
x
not
is always less than 1 by n. Okay.
yes.
So the whole thing will be always less than 1. That's how it's defined. You have defined it, right?
So I can just like disregard this portion.
Yes. So
Okay, so then it is a DF which is degenerated at 0.
no. Like when x is equals to 0, what is the problem here? What is the problem here? When x is equal to 0, the nx will be 0. In that case, you have taken equality there, na? You have written in the distribution function that if x is strictly less than 0, it is 0. If 0 less than equal to x, that you have written, na? Nx equals to. Hello?
Yes.
So you have considered equality in the second case, right?
Yes. Okay.
So when x is equal to 0, then what happens? The entire thing will be 0. So now, what is the distribution for limiting distribution here?
I could not hear.
Like,
Could you?
I cannot see it. Hello. Can you hear me?
Yes.
Hello. Okay.
Yes.
So what is the final distribution function? I cannot. Okay. Yes. Now I can see it. Okay. So is it a distribution function? Like, what are the properties of
No,
distribution
it's
function?
not a distribution function.
How can you say that?
Because the properties of a distribution function, one of the properties is that it has to be right continuous.
Yes.
So it's not
So
right continuous at 0. So
yes. So can it converge to a distribution? of a random variable?
No, it cannot.
Think it properly. Like, what is the definition of convergence in distribution?
Okay, so convergence in
Yes.
distribution is that if I have a sequence of random variables x1, x2, xn with corresponding sequence of dfs f1, f2, fn,
Okay.
then xn is said to converge in distribution to x if the corresponding
Yes.
sequence of dfs converges in no. So if limit n tends to infinity, fn x is equal to fx, where f is basically the distribution function
The
of
function
x
of the x. Okay. Okay, I got it.
for all continuity points of fx.
Yes.
Okay,
So now can
0,
you tell anything?
yes, so 0 is a discontinuity point.
Yes.
Okay.
Yes.
So
0 is a discontinuity point. So what can you do now?
so it converges in distribution to a random variable x which is degenerated at 0.
Okay. Okay. That's perfectly fine. Okay. So my next question is, suppose x1, x2, xn is Bernoulli P.
Could you please repeat?
x1, x2, xn is a random sample from Bernoulli P.
From?
Bernoulli P. Bernoulli. So find the UMV of indicator P greater than half. UMV of indicator P greater than half.
Greater than half.
Half, yes. What you have written there?
So this is basically what you said, right?
Acha, acha, okay, 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 okay.
I mean, this is a parameter, right? He's
Yes, yes. P is a parameter. Yes. Like we want to estimate a parametric function, right? We don't want to estimate any statistics or sample. We want to know some information about the parameter. So this is a parametric function. So we can estimate it. Like what is the UMV of this thing? What do you think? Like what are you finding at first? Hello?
yes.
What are you trying to find at first?
We want to uh,
Yes. So what is an UMV? What is an UMV?
so the UMV is basically the UMV of a parametric function is that unbiased estimator which has
Yes.
the minimum variance among the class of all unbiased estimators.
Okay. So at first you have to find an unbiased estimator.
Yes, right.
So can you find that? Okay. Suppose you have found the unbiased estimator, then how can you convert to UMV? Do you know that?
Yes, I can convert it using Lemon-Sheffy theorem.
Okay. So what does it tell?
Well, Lemon-Sheffy theorem states that uh, if H is an unbiased estimator of a parametric function, and
Yes.
if T is a complete sufficient statistic, then
Yes.
the expectation of H given T is the UMVA of that particular parametric function.
Okay. So will it be unique?
Sorry, I could not hear.
Like, will the UMVA be unique? Like the UMVA that you got from the complete sufficient statistics, will it be unique?
Yes,
How, why? Why is it so?
because when H is, I've stated that H is unbiased for,
Yes.
let's say, a psi P.
Yes.
Expectation of H is psi P. I want to show that expectation of H given T is also
Hmm.
psi P.
Okay.
This will actually be equal to expectation of H because the distribution of
Okay. It will be unbiased. Okay. Just tell me
yes,
about the variance. Yes.
variance of this will be less than the variance of H.
Why?
Uh, we can show it like this.
Okay.
So yes, so I want to show that this quantity is less than this quantity.
Okay. Okay. That's perfectly fine. Okay. 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 I got it. Now, if you take like, then what is the role of complete sufficient statistics here? Like, if you use any statistic, theory will hold, right?
I could not hear
Like,
that actually.
hello,
So
hello. So hello. So if you take any statistic, then
yes,
the above expression you have written is true, right? The expectation of H will be like less than the variance of H given any statistic will be less than equal to that like variance of H, right?
yes.
So how can you claim that it will be the UMV? Like, don't have to tell me it mathematically. Just tell me intuitively. That will be fine. Like, what is the specific property that gives us the uniqueness of the UMV? If you try to use a complete sufficient statistic, what is the particular property?
I, actually, I could not get that problem. I cannot.
Okay,
The
okay,
voice
okay,
is
okay.
breaking a
Okay,
little.
so my voice is breaking. Hello,
Yes,
hello.
just a little
Okay,
bit.
okay, 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 okay. So I'm asking that if you use a complete sufficient statistic, like what is that particular property that gives us the uniqueness of UMV? Like, which one among them? Like completeness or sufficiency?
Completeness.
Okay, 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 got it. Now try to find an unbiased estimator of this parametric function.
I have to find an unbiased estimator for this.
Yes, 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 yes. If you can find an unbiased estimator in terms of this complete sufficient statistics, then you're like you will get the UMV, right? So can you get an unbiased statistic based on this? What is the distribution of summation xi?
Binomial NP.
Okay, so suppose Tx is Tx is an unbiased estimator, then what will be the expression for the expectation of that thing? So can you find such an estimator? What do you think? Can you find what do you think? Can you find such an estimator? Will such
No,
estimator exist? Why? Why do you think so?
I mean, I know that for a binomial NP distribution,
Yes.
the estimable parametric functions are of the form are basically polynomials of degree less than equal to n.
Yes. Yes. So, like, can you
Because I have
justify that it will be you will like we will get a polynomial from this? Can you justify here, like from the structure of the expression?
this expression.
Yes. Yes. Can you justify that? Like, just give me an intuitive idea. That will work.
It is a polynomial of degree x because this
Oh,
is basically
degree x. No, like what is the maximum value that the power of p can take here?
the power of p can take a maximum of n.
Okay. Okay.
So when I
And what about this tx? What about that tx? Can it
uh,
give us any like anything regarding p? Any term regarding p?
I'm sorry, your voice is breaking. I could
Like
not.
I'm asking that is this tx the tx that you have written?
Yes.
Can it give anything regarding p?
Can it give anything
Like
regarding p?
yes, any term regarding p? The tx that you have written.
No, it cannot because it's a function of the sample, so it cannot give
Yes.
any term
So
regarding.
it cannot have any, it cannot involve anything regarding the parameter, right? Like any
Yes,
term
right,
regarding the parameter. Okay. So what do you think? Like this expression cannot be estimated unbiasedly, like right?
right, right.
Okay. So that is the answer. That this expression cannot be estimated unbiasedly. So there is no concept of UMPV. Okay.
Right.
Okay. So I'm done. Now, do you have any question?
Uh, yes, I mean, regarding this interview or about how.
Regarding this interview? Regarding this interview or anything else you can ask.
Yes, I mean, I think it would be nice if you could tell me. I mean, I don't have a lot of time left, like about a week or something.
Hmm.
So, how do you think I should divide my time at the moment, or what I should focus on? What would be best?
Just focus on the basics and the definitions. Okay, so they will ask some unknown questions to you. Okay,
Okay, okay.
yes, so they will ask something unknown to you, so you have to build that from your basics. So just strengthen your basics and just focus on the counter examples also. Like if you know the basics, you can build upon that to prove a theorem or something like that, concepts related to that. But try to think about the counter examples also. Suppose the convergence in distribution doesn't imply convergence in probability. Okay,
Yes,
suppose
yes.
they asked you to give a counter example, so unless if you don't know that, then you cannot answer, right? So try to revise all those things. And how many questions you have attempted in PSB?
PSV, I did 7.
7. Okay, and how many of them according to you is correct?
Actually, I did not leave any part, so I checked with the solved PSB, okay, that some people had uploaded,
Okay.
and most of them
Okay.
are right, except for like today morning
Okay.
I was looking at problem 10, okay, and the method was right. I proceeded with the likelihood
Lagrange.
function and everything, but I think in the end I wrote something wrong. Like the result, the answer was probably wrong. So
Okay. Okay. So that's a silly mistake, right?
yes, it is. It is.
Okay. Okay. So
Not a
try to try to revise all the questions in PSB and PSA part also. They can ask question from that. In my case, they modified a question from PSB and asked me that question. So they will see your approach basically. Okay. So they will give you hints. So don't panic. Just be calm and listen to them carefully, like what they are trying to say, what hints are they giving. Okay. So try to capture their hint and you will build it. Okay. So you have that foundation. You can build that. Just be calm and take your time and everything will be okay.
And if any part you think that you have done wrong in PSB, try to focus on that also, because they have your copies. Okay, they will have your copies, so they can ask you from there also. Okay, and if you are trying to approach any sort of problem in your way, be confident about that steps, because if your PSB part have gone well, so they will know that your foundations are very clear, so they will not ask you some very obvious or very basic questions. But once they start a problem, they will start from the basic, but then they will be keep diving into the depth of that. Okay, and they
okay.
will check at every point of the basics that are required for that particular problem, like the way that I have asked you. So these things they will also do. So keep that in
Okay.
mind. Otherwise, your foundations and basic concepts are very clear. That's pretty impressive. So wish you all the best. Okay.
Well, I also
Yes.
wanted
Best
to
of luck.
ask, thank you. So from today's interview, what would you say? I mean, what things do I need to focus on only based on today? I mean, how I performed.
You perform well. Because you have to use that hint and you have used that hint very very nicely. Okay.
Oh,
So your
thank you.
interview got very well, and yes, try to focus on the basics. Okay. Try to focus on the basics and you will build it. You can build that. Just be calm and confident.
Okay,
Okay.
thank you, thank you.
Yes.
So can I leave the meeting now?
Yes.
Yes. Yes. Yes. You
Okay.
can.